So in the mid-1930s, Enrico Fermi attempted to synthesize a new element. He bombarded uranium with neutrons. You know, sometimes scientists are just like, hey, let's see what happens if we do this. The theory was that if the neutron was incorporated into the nucleus, it might undergo beta decay and convert the neutron into a proton. And so they were thinking, well, we could end up with this new element. He did detect the beta emission, but he never actually chemically examined the products to see if he had formed a new element. So he was trying to take uranium-92, the largest naturally occurring element, and make something with a larger atomic number. Lisa Meitner, Fritz Strassmann, Otto Hahn repeated Fermi's experiments. They did look into what the products were, and they found that the products were several elements that were lighter than uranium. So instead of making a larger atom, smaller atoms were made. And this was a discovery that changed the world. 1939, they reported the neutron bombardment of uranium resulted in nuclear fission, the splitting of the uranium atom. So it was known that some atoms would spontaneously emit particles, but until this time, you couldn't break an atom. They discovered that, yes, you can break an atom into pieces. Atom smashing is another term for it. So the uranium atom split into a barium atom, a krypton atom, and 3 neutrons. And in that process, an enormous amount of energy was released. So this was uranium-235. Uranium-238 is the most common isotope. It does not undergo fission. Less than 1% of uranium is uranium-235. So you have to have the right kind of uranium to do this. If you have a sample that has a significant quantity of uranium-235 in it, it can undergo a chain reaction. So you bombard the one nuclide with a neutron, and you induce fission, and that splits into a krypton and a barium and releases 3 more neutrons. Those 3 neutrons can possibly each cause fission in another uranium-235 atom. So this atom releases 3 neutrons, this one releases 3, this one releases 3. If that continues, it will explode. That reaction can be used to make a bomb. It's a chain reaction. If the sample was pure 235, it would definitely explode. The chain reaction would continue. It is not necessary, though, to have pure uranium-235, but you need a certain percentage to be uranium-235 for that reaction to be self-sustaining, and that's called a critical mass. So during World War II, the U.S. was afraid that Nazi Germany would develop an atomic bomb first, and so we developed the Manhattan Project in Los Alamos, New Mexico. The first nuclear weapon was detonated there in 1945. It had the force equivalent to 18,000 tons of dynamite. At this point, Germany had already surrendered, but we did drop 2 bombs on Japan, killing 200,000 people.